Could we control active packaging activity? The answer is yes, we could. I am Adriana Juan, a PhD student of the University of Alicante, and in our research group have carried out an optimization of UV activation for double function oxygen scavenger and aromatic food packaging films based on low density polyethylene, polybutadiene, and peanut aroma. One of the main problems of the nut industry is the reduction in the shelf life and quality of food samples. Currently, to improve the shelf life of nut products, food industry uses different approaches, such as the modified atmosphere packaging. However, the residual oxygen concentration in the package often remains between 0.5 and 5% despite using modified atmosphere packaging, and it can increase during storage since oxygen can permeate through even high barrier polymetric matrices. To solve this problem, in the last years, some research studies have been focused on the development of new active packaging materials by the incorporation of an oxygen scavenger into the polymetric matrix. Those compounds remove oxygen from the heat space of the package, thus reducing the possibility of food oxidation, increasing its useful life, and maintaining its quality. Specifically for those who have a high unsaturated fat content, due to oxidation reactions that lead to a deterioration of the flavor and aroma, color alteration, and nutritional losses. Additionally, oxidation reactions produce potentially harmful substances such as hydroperoxides or aldehydes and ketones as primary and secondary oxidation products, with the consequent repercussion on the consumer's health. Taking all into account, in this work, a double-function oxygen scavenger and aromatic food packaging films have been developed. The packaging solution, on the one hand, integrates polybutadiene as an oxygen scavenger, and on the other hand, it incorporates peanut aroma to improve customers' sensorial experience. Different formulations based on low-density polyethylene, commercial peanut aroma at 5%, and polybutadiene at two levels, 5% and 13%, were obtained by cast film extrusion. Polybutadiene is well-known as an oxygen absorber due to its double bonds, which are oxidized upon exposure to atmospheric oxygen at room temperature, producing polyketones. Despite overcoming cast extrusion issues, its low oxygen scavenging capacity has steadily hidden its uses as an oxygen absorber. However, polybutadiene increased its oxygen absorption capacity after UV light irradiation. Consequently, polybutadiene packaging could be activated by demand. Regarding the oxygen capacity of the films, values of 2.7 milliliters of absorbed oxygen per gram of the film were obtained for films with 5% of polybutadiene. Values of 4.4 milliliters of absorbed oxygen per gram of the film were obtained for films with 13% of polybutadiene. Prior research involving roast peanut flavor have reported that many of the substances perceived by evaluators are aldehydes and pyrrazines. In this sense, pyrrazines are responsible for the roast and nutty flavor in peanuts, and non-null produced a milky and toasty flavor. Accordingly, 2,3-dimethylpyrazine, 2,6-dimethylpyrazine, and non-null have been employed in the present work as an indicators of the aroma incorporation in the developed films. Based on the sum of the individual retention of the main aroma compounds, the retention capacity of the aroma in films with 13% of polybutadiene was significantly higher. In conclusion, the incorporation of polybutadiene at 13% into a a low-density polyethylene matrix improved the retention of the peanut aroma, being this behavior attributed to the ability of polybutadiene in enhancing cross-linking of the low-density polyethylene as the concentration of polybutadiene increased. The results suggested the potential of the films with 13% of polybutadiene and 5% of peanut aroma as an oxygen scavenger and aromatic food packaging system to offer protection against lipid oxidation in nuts, improving also the consumer's experience, avoiding the use of additives or additional packaging elements.